Hey, check out that sweet charge indicator on the front of this RANGER XP Kinetic. This thing's almost fully charged and ready to go. Today we're diving deep to show you guys how power flows from the wall to the wheels and how everything in between works. All right, come on back and follow me to the wall so we can see where power starts getting into this Ranger. So when you get a new vehicle, you actually get two of these adapters, one for a 110, one for a 220, 240 outlet, depending on what you got in your shop. Today we're gonna be using the little guy, so we'll get a slower charge rate, but it'll at least demonstrate since we're too far from the other outlet here. So first thing you do, jam that into your box here, get that plugged into your wall. In this case, we got 20 amp outlets. You can see by the little line on the side. And then grab the other end of the cable, which is your charge connector. Flip open the door on the side, open that thing up, get it lined up, push it in until it clicks. You've now enabled charging on your RANGER XP Kinetic. So super easy to get this thing going and charge it. Now I'm gonna walk around so we can kind of show you how the power flows through this vehicle. So you can see where we plugged it in on the side. And then you follow, there's a big orange cable that comes down. It actually goes right into this box right here. This is the charger on this machine. So what this guy is doing is it's taking that AC input from the wall and it's actually converting it to 100 volt DC power coming out these two cables right here and going into this high voltage battery pack. So that fan's kicking up to let you know that it's working. We might just let that taper down for a second. But this 100 volt battery pack here behind the passenger seat is kind of the heart of this RANGER XP Kinetic. This model particularly is a single battery style setup. If we had the dual battery packs, there'd be another one right here underneath the driver's seat. So kind of where you see this open void of space, that's where the second battery goes on the 29.8 kilowatt hour version of this vehicle. So from here, we've got power coming out at 100 volts. The next thing we're gonna do is go over and you see that there's a couple black boxes here that are labeled DC to DC converter with a giant finned heatsink on the back. What those guys are doing is actually taking the 100 volts off the battery pack and dropping it down to a normal 12 volt and actually charging this battery right up here that's kind of underneath the passenger's left thigh under the seat. So this 12 volt battery is the same style you'd see in any gas Ranger for the most part. And that's there really to provide power to the loads that are normal or standard on a gas vehicle. So think of things like your taillights, your headlights, your gauges, your power steering unit, and even the 12 volt outlet that exists in the back box of this machine. So you've got, all the 12 volt protection is here underneath the seat. So standard relays and fuses, and then some bigger ones for the DC to DC converters along with the rear pulse bar and a couple other things. You've got your diagnostic connector port. So this is for plugging in digital wrench at a dealer. The other one that people may not be aware of, this is actually, you can see here, removed during service. So if you ever have to work on this vehicle, you actually want to pop that connector off and that will disable the electronics, so it makes it a much safer environment for you as a, for anyone that's a technician working on this. So you can see that little service port connector there. So we'll maybe leave that off while we're pointing on everything else here. And then what you'll also see in the back here is there's a couple giant relays. These two things actually control these DC to DC converters turning on and off. So these are the high current switches that actually allow these to come on and off as this vehicle is being utilized here. So again, going back to the battery now, so we got to get 100 volts from here back to the motor. So the next thing, if you follow these two giant cables out and back, they actually wrap down under the motor and come back to the motor controller that's right back here. But you can see we got plus and minus coming into the motor controller here. So these two are 100 volt DC bus. And then you got the three phases, U, V, and W. Those three cables are actually what's feeding that motor. So it's a three-phase AC induction motor that those three cables are feeding into this, this pancake motor here. So basically this thing is going to vary the frequency to be able to drive that motor at different speeds, and it's going to put more or less power into it through this motor controller. The other thing that you guys are going to notice in the back here is that there's a couple coolant hoses that are running to the base plate on this motor controller, and that's actually for a liquid cooling circuit to help keep the motor controller itself cool, because there's a lot of high powered electronics that run through this. So there's a tiny radiator on the back of the vehicle that you might be able to see here. There's also a tiny electric water pump that's right down here as well, and you can see the coolant cap is here. So this entire coolant circuit actually exists on the back of the RANGER XP Kinetic, and it's really just for cooling this motor controller down. So we got three-phase power. Next thing that goes to is this giant electric motor. So it kind of looks like a stack of dinner plates back here, but these are all cooling fins on the motor controller or on the motor itself. This is actually coupled to a drive cog belt underneath this cover that goes right to the input shaft of the transmission. So this is kind of a standard style of transmission like you'd see in most other Rangers. The difference is that this has got park neutral, low and high. There's no reverse gear in this gear set because this motor can spin both directions. So when we think about this motor, we've obviously got the controller that's going to control the direction and speed of this motor. But where does this motor controller actually get the inputs and signals it needs for the smarts to be able to, tell this thing what to do? Well, we've got a few other controllers here. When we go back to the interior, we've got two kind of magic black boxes here. One's called the main bike board, one's called the VCM. This little guy is really acting as a network translator. So this is basically talking, kind of power steering language along with the electric motor controller language so that those boxes can talk back and forth. That translation happens in here. And then this guy is actually what's taking all the user inputs like throttle, brake, that kind of stuff, feeding them in so that we can actually control the motor controller, communicate with the battery management system that's in the battery pack, communicate with the charger, so that all these things can kind of live in unison. So how do we make this lithium ion battery last? Well, it comes down to a couple things. Number one, we've got an awesome charger, right? So that's going to prevent too much power flowing into this battery too fast. The other thing that's inside of this is a battery management system controller, along with current sensing, along with hydrogen sensing, and a couple other things. And the cool thing about that is that it's able to monitor the cell health and adjust the current flowing in and out of the battery automatically, so you don't have to worry about it. So that's going to basically balance the two halves of the battery pack so that you get an equal amount of power flowing in and out of each one, so that you're not, overstraining one half of it versus the other. So inside, if we actually, had this thing torn apart, you'd see a whole bunch of flat pack battery cells that are lined up on each side, and then an electronic controller kind of sitting up on the top over that. But overall, this battery pack is a really cool piece of tech, and it's really set up for long longevity on this RANGER XP Kinetic, and a 100-volt pack. So that's a little different than somebody was used to maybe our old RANGER EV unit that ran all lead acid batteries. That one was more of a 48-volt system. This one's moved up to 100 volts, so we can actually downsize some of the cabling on this because we don't have to pass as high a currents through all the wires and cables. So overall, really awesome battery, really good longevity here out of this high voltage battery pack. So when you think about it, there's a lot going on all the different controllers and all the different bits underneath the seat here. But just remember, power starts from the wall, flows down the cable, comes to the charger. From there, it goes to the 100-volt pack. The 100 volts either goes to the motor controller and motor or through the DC to DC converters for the 12-volt circuit that's done off the battery here. Some of the things that are similar to what you're used to in a Ranger, again, headlights, taillights, gauges, all powered off the 12-volt along with the power steering. So there's some things that you're kind of used to, some things that are running on this 100-volt bus, but overall this RANGER XP Kinetic is full of great tech. It's highly durable. You can see all the connections are nicely sealed up on this stuff. So this thing's ready for the off-road environment and ready for what you're going to put it through. So we covered off on how the power goes from the wall all the way back to the wheels on this RANGER XP Kinetic. So what does that mean in real world driving, when you think about range? That's something we get asked about a lot when we're talking electric vehicles. Well, on this one to my right, you've got a 29.8 kilowatt hour battery setup. So this has got the dual batteries in it, the one on the side, one under the driver's seat. And if you think about how far you can go, we did a lot of testing, and we actually talk about this as like, a driver with, about 250 pounds in the box, right? So kind of a normal, maybe task-based use around the farm. Well, if you think about somebody sitting on 80 acres, you could literally drive the perimeter of that property about 150 times before you'd run out of juice. So when you think about it, you got a ton of range. That's probably 6 to 8 hours of use, almost continuous. And a lot of times when you're using a Ranger, you're not always moving, right? If you're running fence, if you're stacking wood, you might go a little ways, stop, go a little ways, stop. So you're going to be able to go pretty much all day in one of these RANGER XP Kinetics before you got to plug it into the wall, let it charge overnight, and it's ready for you the next day. So overall, this is a phenomenal machine. I think we've got people that are achieving the real range that we talk about here, unlike, some other industries where they maybe tout off a number, but in real use conditions, you never get that much. Now, to be fair, if you're towing, much like a gas vehicle where you're going to use a little more fuel there, if you got this thing fully loaded, you're towing a lot, you're going to go through that battery a little bit faster. But overall, for most Ranger, use cases, this machine's going to go all day and it's going to be ready for you the next day after you plug it in overnight. Hey, check it out. We're charged up and ready to go. That's it for this episode of Shop Talk. Be sure you like, comment, and subscribe. Let us know what you want to see next time.